All right, guys. So, the correct way to do this, I'm not picking on anybody because I saw several people do this, especially on this first problem. It's pretty simple to tell what x has to be. But you can't, solving an equation is not putting the answer in and showing it works. That's what's officially called guess and check. Some of these are going to be pretty damn simple, but they're just so you can get used to the steps you have to take for the more disgusting stuff. So the whole goal, what is the goal for an equation, trying to solve an equation? To get x equal a number. Because then I know what x is. And that's what solving an equation really means. Figure out what x has to be to make this true. So that goal translates into, well, how do I get there? I get rid of everything else. And that even goes further. Get all my x stuff on one side, all my number stuff on the other side. You kind of with me? So every single thing that we have to do, the more complicated the equations get, everything we do is driven by getting here. The more complicated they get, the more weird stuff I got to do. But it's still driven by getting x by itself, stripping away all the other crap. So here I've got x plus 5. 5, positive 5 here, right? So how do I get the x by itself? I want to get rid of the thing that's with it. So then you want to subtract 5. Whatever you do to one side. And a real quick word on that. I'm going to break this thing down like crazy. Everybody agree with me that this is true? Yes. Now, if I subtract 2 from this side, is it still true? No. Of course not. So to make that still a true statement, if I do anything to one side, I have to do the same thing to the other side. And then it maintains its truth. Or truthiness, if anybody ever watches Colbert. So if I subtract 2 from both sides, is that still true? Yes. Right. So that's what's governing me here. I know my goal is to get x by itself. I know that means I want to get rid of stuff. And the legal way to get rid of stuff is to do it to both sides so that the truth is maintained. So if I subtract 5 here so I can get x by itself, I've got to subtract 5 here also. So then I get x equals negative 2. If you check it, negative 2 plus 5 is, of course, 3, so it works. Okay. How are we doing with that? So that is extreme in-depth analysis of this very simple seeming equation, but it's got a lot of kind of stuff hidden in it. And we all, again, very different backgrounds. It's been a long time for some of us, so forth. This one I did on purpose. There's a couple different ways to do this problem. If you look at it the most straightforward way, you'd say, what's in the wrong place? All my x's are right here, so what needs to get away? The 5. So you can subtract the 5. Well, what's left on this side now? Good. That minus can't suddenly go away. It's still negative x. So I don't stop there, because you don't have x by itself yet. How do you get rid of that negative in front? What's kind of understood to always be here? So then you divide by that thing you don't want. So you get x equals negative 2. The other way to do this problem is to add the x to the other side, which is kind of nice because then it keeps your variables positive. So if I added x first, I get 5 equals 7 plus x. And then what's in the wrong place? The 7, because it's with the variable. I don't want that over there. Subtract the 7, negative 2 equals x. So I end up with the x on the wrong side, but there is no wrong side. It's fine. It still says x is negative 2, right? So either way you want to do that problem, beautiful. How are we doing so far? Yes, ma'am.
I got negative 2, but I completely skipped dividing by 1. Is that okay?
Oh, I see. So you got you got here, and then you just did this. I like it. And that's fine too. Because the opposite of what is 2? Negative 2. So, I mean, you can kind of take a step outside the mathematics and just see what this says in English. The opposite of what is 2? Well, the answer is negative 2. There, you're done. You don't have to do the divide by -1, which is purely mathematical. You can actually step out and say, well, that's got to be what it is. So here I start to throw in a little more complexity. But it's still the same idea. I want to strip all the stuff away and keep x by itself. So the very first thing I have to do towards that goal is distribute the 2. Now I had a couple people that were trying to add the 4. I'm not picking on either one of you. I just want to let you know that there's 2 of you, at least that I saw. Why can I not do that?
It's not opposite sides.
The quickest way to say that is, it's not free to move. It's trapped in here. So I've got to distribute first to free it up. I don't have a 4 there. I have a 8 there. Right? So I was trying to tell somebody, if I was making $100, and they said, we're going to double your salary, but then we're going to take $50 away. I'm still okay. I'm going to come out ahead. Unless they try to take 50 away from that before they... No, you can't take 50 in. You can't break in there. Screw you. Double it first, and then you can take something away. Are you kind of with me? If they did that, I'm making the same money I was before. The hell? So I can't break into this. I've got to free it up. In fact, if you put a +4 next to this, order operations says you have to do multiplication before you can do addition anyway. So I've got to distribute that 2 first. So I get 6 plus 2x minus 8 was 11. Cool. So that really just breaks down to anytime you see any distribution problems in an equation, you do those first. Then you've got all the parts that can move around.
Then they added 2.
Oh, good, yeah. So on this side, you get your like terms together. 6 minus 8, -2. And see, the 11's just coming for the ride because there's not a damn thing to do to him. And then, why is my piece with an x in it not by itself? Yeah, I got a -2 here, so what do I want to do to get rid of it? Add 2. And then finally, divide by 2 to get the x by itself. Okay, cool. So the only difference between these problems and this one is that I added that distribution step in there. So whenever you see this kind of thing in a problem, you got to distribute first, so then you can start putting like terms together.
Now it doesn't matter if it's an improper or proper fraction, right? The answer.
No, unless I say something specific. You could make this. What would it be as a
6.5.
mixed number? Yeah, 6.5. I like it. So number 4, I just, added more stuff in there.
-3 up to 6.5. Is that cool too?
That's fine, except I don't like to see. I like the answer. I don't like to see decimals too often. If you showed me this and then you said 6.5, that's fine.
Oh, well.
But if I see too much reliance on calculators where you don't really need to, I start to worry.
Nah, it's in my head.
I got you. Yeah.
I don't think it matters, but I just did it. I mean, I got the same answer, so I don't know if it just worked out, but I did instead of the like 2x minus 2, I just did -2 plus 2x. Doesn't matter.
I love it.
Still
Yeah, exactly. It's the same thing. So 2x minus 2 is the same thing as -2 plus 2x. Those are the exact same thing. They both have a positive 2x, and they both have a -2. That's actually a really good thing to realize, because it helps you realize why. Let me see. Do I have a problem? Yeah, like on this problem, people say I should add 5 because there's subtraction here. But this is a positive 5. If I wrote this the other way around like we did here, 5 minus x is the same thing as negative x plus 5. So that's really why we had to subtract 5. Because the 5 is positive. It would be added to the negative x if I turned it around. So I'm glad you brought that up. Cool. If I added 5 to both sides, this would be 10. It wouldn't cancel. That would suck. So what about... Oh, sorry.
The last step on number 2. No, what is the bottom of the blackboard?
Okay. The last step.
Later.
So I added 2 to both sides. Then how do I get, then I have 2x equals 13. And what's the operation here? What's the operation in 2x? What are they doing to each other? Multiply. Right, so let me bring this up here. When I see two things sitting next to each other, in mathematics, two people sit next to each other, I don't know if they're multiplying. So this means 2 times x. And since my goal is to have x by itself, I want to strip away anything that's with it. What does that really mean then? I want to do the opposite operation with whatever. So to kill the 2, since it's multiplying, I divide by 2. Just like here, to kill the 5, since it's adding, I subtracted 5. I'm always doing the opposite operation. And that's why we ended up there. Cool. So I do see a lot of this. I do see a lot of this. Right. This is a mistake. This is not an option. This is a mistake. Right? But you can see what they're thinking. They're focused on, I want to kill the 2's. Let me just subtract 2. Subtraction cannot cancel multiplication. Right? So some of you will see me write that on your papers. Subtraction can never cancel multiplication. That won't work. You'll end up with 2x minus 2. That's bad. You're just packing more stuff on that side. That's no good. Okay. So what about number 4 up here? Which piece do I have to attack first? Yeah. And again, I still think a lot of you guys see the whole thing at once. The very first part of this that I'm worried about is just that. And if I gave you this problem by itself, you should be happy about that. You should be like, give me more of that, Jeff. Right? Just distribute that number through. The one thing you got to be careful about on this specific one is it's a negative 2. So 3, negative 2 times 2x. Good, negative 4x. Negative 2 times negative 4. Plus 8. Good. So the most common mistake there is people put a minus 8. But those 2 negatives will make a plus. Is that cool? Okay.
That's always a rule, right? 2 negatives multiplied make plus.
Exactly, because it's like the opposite of the opposite of. Well, those cancel.
Opposite of opposite of? What?
Exactly. So.
I think I was understanding until you said that.
No, I got you. And so I said this the other day. It's not like telling somebody to turn around and turn around again.
Yeah.
You end up facing the same way you were. So the opposite of happy is sad. So what's the opposite of happy? Happy. So the 2 opposites cancel each other out. So it happens the same way in mathematics, right? But if I put 2 sad people together, then they're just even more sad. You with me? All right. I don't know if I want to go down that road. Misery loves company or something. So which side can I do stuff with? So I desperately want you guys to... we have a goal. We want to get x by itself. If I have a lot of crap going on in my equation, my first couple steps are going to be freeing stuff up and getting stuff together. I can't even start working directly towards my goal yet. I got stuff to think, and then I got to get stuff together, and then I can start getting x's together, numbers together, right? So all I did there was bring the negative 2 through. Now I can get like terms together. It's kind of the cleanup stage. So what goes with the 3? 8. And the negative 4x plus x is minus 3x. So now I can start moving stuff around. And it doesn't matter which way you go, but who's got a suggestion which way I should go? Yeah. Don't worry, we'll do that problem. Next one. So plus 3x. That'll keep my variables positive. Not a bad idea in general. So they cancel here. You have 11 left there. The equal sign is still there. 7 is still there. What do you have here? Plus 2x. Cool. And now what's in the wrong place? The 7. I got x's all together here. The numbers are not together yet, so I want to get that 7 out of there, so I subtract, so it cancels over here. So I get 4 equals gone, 2x. And then the last thing I do is almost always divide.
See, I did it again. I did it something completely different. And I don't think I did it right at all, but I got it right.
Well, show me. You might have been okay.
You added the x instead of the 3x.
Well, first of all, I had a -8. I didn't even have a +8, but I still somehow ended up doing 11
What'd
minus
you-
3x.
Oh, okay, so if you have a -8 there, it should have been -5 here. So very often what happens is 2 mistakes cancel each other out. So then a student really gets upset at me if I take points off, but I think you all understand I've got to take points off. 2 mistakes is twice as bad as 1. I don't care if they cancel each other out, right? You just got lucky.
Yeah, and then...
But as long as you understand right now why what you
See,
did was
I'm looking at
wrong,
My mistakes. I'm just...
and this is a really stupid, easy thing to forget. This is a really easy thing to forget. I'm not saying it's okay to always do it, but I'm saying don't beat yourself up if you do it every now and again. Where this stays a minus, because your brain just looks at that 2 and thinks about it like that. But here's the way. Sometimes I show people. You guys got all this here?
Thinking of that. I might have been thinking
No.
of
Okay.
So I took my negative position.
Here's one way to write this. So let me write this one time, and I'll see if it makes a little more sense. You guys, well, let's see. Let me first start off with, do you realize you can write 7 minus 8 as 7 plus -8? Those are the same two things. If I have $7 and I owe $8 to somebody, I can add $8 in debt to what I got. That's why they mean the same thing. So right here, you could write this as 3 plus -2 times 2x minus 4. Now you can see it's a -2 going through. It's not just a 2, it's a -2 going through, right? So I don't know if you necessarily want to do that, or if you just need to see it once to kind of get it in your head that that's really what's going on. When I see a minus sign, that really acts as a negative as you bring it through.
I might have been using like the addition and subtraction rule, like if you had 2 negatives, just add them together and keep the sign.
Oh.
Thing. Like maybe that's where I did multiplication,
Yeah, so
but then I
here-
kept the sign.
I got you. So here we're multiplying, so they definitely have to
Yeah.
change. Yeah. Whenever, now let me say this. Whenever the outside number is negative, both the inside things will change signs. So see how the x's were positive? Now they are, the numbers were negative, now they're positive. So whenever the number out front is negative, everything inside will change sign. That's another thing to realize, right? Okay. Don't feel like that's all stuff to memorize. It's just all stuff to help you do it the right way. So what about that last freaky one? Has everybody got this here now?
Yeah.
Cool. Oh, let's see now. What was it?
6 plus 2x.
Not there, right? Okay. So when you start to work this out, twice 3 is 6. So right there, maybe you take a step back and you're like, okay, shit, what the hell? But then maybe you start doing this. I don't know, some of you guys, you could have done this in very different ways. And then maybe you get here and you're like, well, shit, what the hell? But your x's are still not together. If this was 2x equals 2x plus 7, or let's say this is x, you know you'd have to subtract the x over. No question, I need to get my x's together. Just because the 7's not there is not going to change that. I still have to get the x's together. And just because there's a 2 there doesn't change. I still have to get my x's together. So I'd still have to subtract 2x. Your brain kind of sometimes sees that coming and says, oh shit, let's change the rules a little bit.
But I thought you
That's
could
what you
have
lost
to
in
subtract when there was multiplication.
Yeah, when there's a divide.
What's 2x minus 2x? 0. I'm trying to get my x's together here, right? So again, if I had 2x equals x plus 7, how do you get your x's together?
Plus, or
What would you do?
minus.
Minus x. And then what if it would have been a 2x? What would you do? Minus 2x. Just because there's no 7 there doesn't change things, right? I know I'm not ready to divide yet, because are all my x's together yet? No. So I've got to get my x's together. I haven't gotten them together yet. So I have to, that side tells me I have to subtract 2x to get it to cancel. Now that happens to cancel on both sides. So what the hell does that mean? Is the answer 0? No. The answer is not undefined. The answer is either, so I want you to realize, what does this really mean here? This means when this is true, this is true. So when x is 2, x can't be anything else. X must be 2, then this is true. When this is true, this is true. Is this ever not true? Is 0 ever not 0? 0 is always 0. So it doesn't matter what x is. No. So the answer is all real numbers.
Oh, okay. Yeah.
All right, go with me for a second.
It doesn't matter what it is.
Why does it not matter what x is?
X is arbitrary.
Because x cancels. No matter what x is. And notice this. What is twice 3 plus x? What is that? That is 6 plus 2x. Does it matter what x is?
No.
Isn't that just the distributive property? So that's why math says, well, you started with an equation that's like a definition. So I'm going to freak out at the end. It doesn't matter what x is. And the best way math can tell us that, since math can't talk to us, hey, dude, right, is to give me some answer like this, 0 equals 0. It's telling me it doesn't matter what x is. It's always true. So any real number I put in there would be
So
right.
writing always true, you would take both answers. Always true are all real numbers, right?
I need the answer, the solution. So what values of x work? All real numbers. Yeah.
So 0 would not be right.
0 is definitely not right. Even if you check it, it works. But that's because 0 is a real number. Any real number would work. So I really want you to understand. Let me show you another example. And yes, that is tricky. But this is another place where math is really honest. Aren't there situations in real life, if my boss came to me, and last year we made $3 profit, and he comes to me and says, Waller, figure out how we can make $12 billion profit this year. All right. So if I do the equations, math has got to somehow tell me there ain't no freaking way in hell it's going to work. So here's what that would look like. If I start with the bogus problem, what should that be? Tell me, what should that be? All right, so if I write that, we know it's bogus already, don't we? We know going in that that's bogus. That's bullshit. It ain't. So what's math going to tell me? Let's see what math tells me then. Are you with me? This should be 2x plus 2 to be true, and then it would be like this. This will never be true. 2 times x plus 1 can never be 2x plus 3. So let's see what math tells me. So I do the problem. Let's say minus 2x. Get my x's together. 2 equals 3. When that's true, this is true. Is 2 ever equal to 3? No. So this is never true. So what's the solution? No solution. So again, I don't know if you guys understand my point with the whole Waller make us get $12 billion. I'm saying in real life, there are things we want done that just cannot happen. If we set the equations up for that situation, we solve it and we get shit. Because math is trying to tell me, dude, ain't no way. This is math telling me all day long, man. Right? This is math saying, yeah, you wrote down something that's just freaking true. I don't care what x is. Look, x went away, and it's true. So I don't care what x I use, the distributive property is true, right? You guys kind of with me? The other equations we've done are not examples of distributive property or something. I mean, if I have this problem here, that's going to come out with some x that makes it true. 3 times x minus 1 should be 3x minus 3 for it to be always true. This is not always true. There's only a specific value of x that will make this true. Because this should equal 3x minus 3 to always be true, right? So if I start to work this problem out, I'm going to find out what specific value of X makes this statement true. It's not distributed property. It's not something that works for all X's. I want to figure out, okay, what X makes this work? So if I do this, you can draw an X there. The two X's go away. Add 3. So if X is 7, this works. For no other value of X will that work, because it's not a truism. It's not 3x minus 1 equals 3x minus 3. It's not always true, and it's not never true. It's only got a very specific situation when it's true. Now that works also. In real life we say, what will we set the price of our computers at so we make this much profit? Well, I can do the equations, then I say we have to set them at $800. I come out with an answer that gets me where I want to be. Most equations are like that. You with me? But if we say, what do we set the price of our computers at so we make a profit of $80 trillion, I don't think that's going to happen, sir. Right? We're not. Dell can't even do that shit anymore. So we certainly can't do it. All right, hopeful. So I really want you to see how this is not math screwing with you. This is math being honest. You start with bogus shit, it's going to give you bogus stuff. We just have to know how to interpret that. How often does this happen? Not very often. So don't start telling me the answer to everything is no solution, right? Yes, a way out. It's going to be right there sometimes. No. Very infrequently will that happen, right? But it will happen every now and again. So you got to be careful. So let's try a couple more. Since we did some freakiness here, let's go back to non-freakiness real quick. Do these two problems. So away from extreme freakiness and back to normal freakiness. Yeah, you can do that too. Leaving 0 equals 1. Right. And then you interpret it the same way. 0 never equals 1, so there can still be no solution. So you it's the same idea. So I only looked at the x's. You did some number moving too. So your numbers at the end are different. Okay. Kind of like what they both had in common. Yeah, that's perfect. But no matter what you do to that problem, it'll always end up with a non-true statement. So the answer will always be no solution. So I just didn't move those 2's over, whereas you did. But it still ends up being not true. That's perfectly valid. Yeah. You see, it's kind of like, and this is why this whole thing on the right, why it's human. I know I can add C, but at the same time, I know then doing that, she's doing both things at once. It's almost the equivalent of multiplying by multiplication and division at the same time. That I would never suggest as a way to do something. Because it's kind of like looking ahead a couple steps. Right?
So it's not.
It's got advantages, but at the same time, it requires you to understand when it's going to work exactly that way. So I would say it's not preferable because it requires knowing when it's going to work that way. So it just depends if you're really comfortable with something, then maybe that it's quicker. The quicker sometimes translates into more mistakes.
I think you're.
Sure.
Yeah?
No. Yeah. So for this one.
I like it. So how do you get rid of that 7 once you do it? What's the operation? Cool. So every time you see, you look at it fresh, you say, what's going on? Let me do the opposite. Yeah. They're already together. So you would just put X. You would do this to both sides of the, but you're not there yet. See here, these are not like terms. You can't put negative 12 together with 3x. You don't want to control like terms together. You could, but right here you've got x. Those two are right. Because this is x minus 12. So if I had 2 plus 11 plus 8, well, 2 and 8 is 10. That's one way to do it. I can add those together. I gotta add them all. I can add them whatever order I want. So you're gonna take 12 away from 15. They're not like terms.
I got down to negative.
But I'm gonna have to add 3x. X is 3x. You just combine it.
No, that's it.
You definitely can't put a negative 12 with a 3x. Because one's a number, one's a collection of x. Exactly where it's going to go. Now I start moving the numbers.
Yeah, I did that. I did the X.
Yep.
Yeah.
Oh, yeah.
1x plus 8.
I thought like we're supposed to do all even on the chapter 1 review, remember? And I kept myself like halfway through. I started doing all the plans, but I went back and I was like scratching out.
And then you would make
I went every single did it all.
and then I say, okay, what's the operation? Why is the x not by itself? You're going to be opposite.
Negative 3 times 8.
I know. I just copied myself. Yeah, I know.
Trying to get rid of the.
That one mistake. Same second line you have.
I think it's the point. Don't divide by 3. No. Yeah. All right, guys. So here I was just testing you on that thing we talked about this a minute ago with that negative in front. So when you bring this through, what happens here? Negative 12.
Plus 3x.
Good. Plus 3x. Negative times negative, positive. Cool. I'm definitely not foiling stuff out because that x is not involved in that. It's just 3 times this. That x is way the hell over there. So it doesn't come into play. Good. Now I look at both sides. I do a little cleanup first. What can go together here? Yeah, the x and the 3x.
Negative 4x plus.
So it'll be positive 4x. Right, x plus 3x, positive 4x. And what else is still there?
Negative 12.
The minus 12. Cool.
Yeah, I got it.
So a lot of this is consolidation and then just writing what else is there. Right? So I consolidate some of it and then I have to just write whatever else is still there.
But that part where you got 4x minus 12 doesn't matter if that's like flipped right there, right? But mine
It
have-
could be negative 12 plus 4x.
Okay, yeah.
Beautiful. I love it. And now you pick about which way you want to go with things, right? Because now I've got to the point, x is numbers. I need to get numbers one side, x is on the other side. So who did what here?
Minus the x.
Good. Minus the x. Get those x's together. Cancel them out there. 3x. And then
Plus
add the 12. Get the numbers the other way. And then finally,
divided by 3.
divide by 3. Crazy. How's that? Is that all right? Okay.
And then that would, you can put that as 4 2/3, right?
Yeah, this you could put as 4 2/3 if you want to. Cool.
Okay, so I think what I'm doing is, I'm taking that, like it says x minus 12 plus 3. I think what I'm doing is x minus positive 3. That's not right, because I got 2x.
And that's two ways you could look at it that way. I still had a few people that were doing this kind of thing here. And remember, that's like doing the same thing to one side. That's not good. It'd have to be both sides, and we're not even there yet. But you could be focusing on that minus and thinking it's kind of stuck there, and then you move the 3x there. I don't know if that's what you're thinking
I think
there.
that is what I'm doing.
And that's certainly not what it is. That minus is stuck with the 12.
Yeah, that does not go to x.
Because you would rewrite this as plus negative 12. That 12 is negative.
Okay.
That 3x is positive.
Okay.
So that's why I don't even move the damn things. I don't even let myself make that mistake. I just say there's an x and there's a plus 3x, so there's plus 4x.
The actual thing that I did that some people might find useful is if you see, like, if there's a loose one on each side that's a positive, getting rid of the one on the right, for example, would get rid of that loose one on the left.
I like that. So if you see that there's an x here and an x there,
Yeah,
they all just cancel. Subtract x from both sides.
exactly.
I like it. But that's an example of,
It's situational.
exactly.
Yeah.
So the more comfortable you are with the situation, the more you can do things like that. Certainly, I would do that if I saw a 5x here and a 5x there. They just go away. But in general, it's better to go ahead and put your like terms together and then go from there. But if you guys see that x would actually cancel out right there, that's cool.
Yeah. Like it's a lot more useful on this one because that way it gets rid of the x on the far left and then it leaves the negative 12 there.
I like it.
Yeah.
Cool. All right. Anything else about that problem there? Okay. Now, so trust me, there are about 88 million ways to do this kind of problem. There really are. What I desperately try to show you is the way that will get you through all of it. When you start to get more comfortable with these kind of things, there's a lot of stuff like what you just said that are shortcuts to this process. Some of you guys are there, sort of. You can do some shortcuts. You've got to desperately make sure I know what the hell you're doing. Right? Shortcuts are great, unless I don't know what the hell you did. So that's beautiful. I mean, the more comfortable you get, the more ways there are to do things. This one gives people trouble. But it's really the exact same way I would solve this. That looks better. Because there's no fractions. But it's still a mess here with variables in it. Minus 2 equals 4. So what would you do first here? Yeah, so I'm going to do that here.
Wait, how is it the same? Can you explain that?
It's not the same in the way that it's going to have the same answer. It's the same in the way that I approach how to solve it. Here, I would add 2 to both sides, right? And then I would do the opposite of what I see happening to my variable. So right now it's multiplied by 7, so I'm going to... Over there, the only difference is it's divided by 7, so I'm going to multiply. But people get freaked out right here. But really, it's the exact same situation as this. I want to get the thing with my x in it by itself first. So I want to get rid of that minus 2. And now I step back in and say, why is my variable not alone yet? It's divided by 7, so I want to multiply by 7. So So here it cancels. X is 42. Right? 42 is a decent answer.
Could you go about it by getting rid of the x over 7 first?
You could.
How? Because I got stuck trying to do that.
All right.
Wait, so you added the 7 to the other side?
Do it again.
That 6 times 7 right there, that came because you had to do both, same thing both sides?
Yeah, if I multiply this side by 7,
So that's what it is.
I got to multiply that side by 7. Yeah.
So
Cool.
you're not multiplying like 7 over 1, like, or 7 over x, like the reciprocal.
Definitely not. The reciprocal thing, I never want to do my variable on the bottom, because then I'm making my variable go on the bottom. That's getting away from my goal. Yeah. I only want to kill the thing that's with the x. I don't want to kill my poor x dude. Right? So I only focus on that 7. In fact, what really is on the top here is 1. That's why there's a 1 down there. Okay, maybe. If it was 2 over 7, I would have been 7 over 2 there.
Oh, and then that 1.
So what's understood to be out there? 1. So that's why it's 7 over 1 that I multiply. So this problem here, you could kill the 7 first. Yeah.
Actually, you might be answering.
Oh, okay. Some of you guys, it's definitely my Math 88 guys, if you were with me in Math 88, I taught you how to kill fractions in an equation. Anytime you had an equation that had fractions in it, you could always kill it. So whenever you see a fraction in an equation, you have 2 sides. That's what makes it legal to suddenly multiply somewhere, because you do it to both sides. I can kill that by multiplying everything by 7. Because what I multiply both sides by 7, so it distributes here and here, and the other side, and then the fraction's gone. X minus 14 equals 28. And when you add 14, incredibly enough, you get the answer. Cool. So if a few of you guys are trying that, that's the correct way. You got to be real careful, because people will very often, they'll multiply only the fractional part. Nobody can escape. Just because you don't have a number on the bottom doesn't mean you get to, no, I don't think I'll be to multiply by 7 today. I'm fine. No, you have to. You can't escape. Both sides have to be multiplied by 7 if you do this. Yeah.
Yeah. I always wondered, like, in the order operations, of course, it's always said, like, multiplication before addition and subtraction. Now, why wouldn't you just do times 7 on both sides and get through that first?
I did.
Well, minus going to, times in it throughout the entire.
Okay, so what you just said was actually the same thing. I want to show you. Has everybody got this here?
Yeah.
Okay. Let me show you what's really going on here. Here's x over 7 minus 2 equals 4. I want to multiply by 7. Whatever I want to do, I've got to do it to both sides, right? So this side has to be multiplied by 7, and this side has to be multiplied by 7. What does this tell me to do? So, to me, it just makes more sense to me, just right from the beginning, to put 7 next to everybody. That way I won't forget anybody. But really what you're doing, you multiply the one side, that means you distribute if there's multiple terms. This side, there's only one thing, so he gets a 7, right? This side, there's 2 things. They each get a 7. Cool. And think about this. 2 plus 1 is 3. Okay, that's amazing. If I multiply by 7 and I only multiply 2 and 3, is that true? If I multiply that, that's true. Each piece has got to have it happen to them. Okay. Hopefully. Okay. So fractions always find a way to mess us up. This is true. So on the heels of that, let's do one more with some fractions in it. And then we'll move on. I like that. That's funny. What I say is what we'll do. But I like that. Move on. Let's make it. Well, this one's even worse. It's got fractions all over the damn place. Yeah, one thing you could do is just to kind of power through it. Just work with the fractions, and if I forced you to do that, you should be able to do it. But the more clever way to do this is to realize I have an equation. I'm allowed to multiply by anything I want to except 0. So I'm going to multiply by a very smart number.
20.
20. If I multiply by 5, wouldn't that kill that 5? This piece would have no fraction, but these two would still be fractions. If I multiply by 2, great. If I multiply by 10, I actually kill both. But if I multiply by 20, I kill all 3. 20 is the LCD. So whenever you have multiple fractions in a problem, if you multiply by the LCD is the number that has all of those bottoms in it. That's really what the LCD is, if you think about it. So it's guaranteed to cancel all of those out. So if I multiply by 20, what happens here? 5 goes into 20, 4 times. So you get 4x minus 2 goes into 20, 10 times. 10 times 3, 30 equals 20 goes into 20 once. So I got 7 left over there. That looks much better now, right? And I'm completely allowed to do that because there's an equation that will balance me out. The minute I show this to people, they start, if I said 1/5 plus 2/5, you can't go, oh yeah, let me multiply by 5. Well, there's a 5. You can't do that. Sorry. You have to deal with the fraction. There's no equation here to balance me out. I can't suddenly make these become 1 and 2. This is 1/5 plus 2/5, which is 3/5. I can't multiply by 5 out of nowhere. I don't have another side to balance that. But if I have an equation, I'm allowed to multiply both sides. That's completely part of the whole deal with equations. That's the one place where I can kill fractions. And that kind of feels satisfying. So now I got a much better equation to work with. Even though I end up with an ugly thing, I don't care. Yep. Or 9 and 1/4. Is that cool? That's kind of useful. The LCD comes in handy. All right. So I'm not going to power too far for it. I just want to show you a little preview. And to do this preview, I want to show you. All right. So here's a problem. And here's the exact same problem. Now, of course, I don't blame you if you don't believe me. Those are the same problem. This just happens to have specific numbers in for those variables. Do you see that? So if A was 2, B was 4, and W was 10, those are the same thing. So if I want to solve for M, and yes, we are getting into the equations that have no numbers in them. If you understand how to solve an equation, you understand how to solve this. What would you do first here to solve for M? You'd add the 4, because you see the M is here, so you want to get rid of this thing. So over here, what would you do first? The M is here, so you want to get rid of this thing. Now the key question there is, what the hell is W plus B? Careful, that's W times B. W plus B is W plus B. I love it, right? Sounds like, Yogi Berra quote, but oh well. It's the most boring quote ever. But W plus B, you can't just say it's yellow or pineapple or Q. It's just W plus B. I don't know where the hell it is. What's the last step here?
Divided by 2.
Yeah, because that's how you're going to get M by itself. It's to divide by the thing that's in front of it. So over here, what's the last step?
Divided by
Divide by A. Because you got to get rid of that thing that's in front of it. So you get M equals W plus B over A. Now I understand why people don't like this. Because it feels like you don't get anywhere. Right? I understand. But I want you to realize this is set up beautifully. If I know A, M, and B, I can figure out what W is. I can just plug them in and figure out real quick. But what if I knew what W, B, and A were? I'd have to plug, 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 and solve. Plug, 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 and solve. Holy shit. I'd rather solve for M, and then I can just plug, 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 done. Right? If I know what W, B, and A are, this is a much better thing to use than this is. So the ability to work with formulas before you plug stuff in is huge. If anybody wants to go into computer programming, you make a much leaner, stronger computer program if you do this work before you do 5,000 calculations. You save some time if you plug it into this rather than that. Even if you're not going to go into computer programming, you all use computers somewhere. So therefore, you'd like one that runs quickly, right? So which programs to know that kind of stuff. If you're going to go into statistics, maybe, someday possibly, you're going to be doing a little bit of manipulation, in that case, of Greek letters. They're going to be flying all over the place. Oh, yes. It's extreme fun, I love it. Okay, and that's plenty. So we made it through, we took a little baby step into section 2.3. So we're through 2.2 officially.